In this section, we're going to start solving equations that just have one variable. But a way that you can start, before you start actually writing down the solving on paper, is you can use manipulatives. And if you don't have any actual balancing scales that you can buy, you can draw them on paper pretty easily. But the idea is that the equal sign means that the two sides of the balancing scale are equally weighted. So when you put items in each side of the scale, one is not heavier than the other. They actually level off and they weigh the same amount. So when we start off solving, I would recommend maybe starting with some balancing scales to get the idea across, and then you can drop the scales and just write it on paper. So here's how the scales start. Well, we're going to start off with, I put A on the left side and B on the right side, and as long as they're evenly weighted here, then that means A is equal to B. So then you can see what I did is I put C on the left side and I put the same amount on the right side. So I added C to the scale. So then the left side is A plus C and the right side is B plus C. And as long as I add the same amount, then the scales should not have shifted. They should have stayed balanced. So this kind of proves that A plus C is equal to B plus C. Or you can start off with A equals to B, and then you can like double or triple the number of A's and B's that you have. So if A is truly equal to B, then if I were to put 3 A's on the left side, that should equal 3 B's on the right side. So you could like add another A and B and add another A and B, and you can show that if you multiply, if you have 3 A's on one side, it'll equal to 3 B's on the other side. So in other words, multiplying is, as long as it's done the same to both sides, then it's fine. So one shows adding, one shows multiplying. So let me show you how you can actually solve a problem using the balancing scales. This is how we're going to draw it. So we have, on the left side, we have 2 triangles and a circle. And on the right side, we have a 10 and we have a circle. So if those two sides are actually balanced, then what that tells me is that I could remove a circle from both sides and they would stay balanced. So what I'm going to do first is I'm going to remove a circle. So I'm going to literally like lift it off. So then this guy's going to be gone and this guy's going to be gone. And what I'm going to be left with then is the 2 triangles on the right side, or on the left side, sorry, and then 10 on the right side. So if these 2 triangles together equal 10, then it should be pretty easy to figure out how much the triangle is equal. If the triangle plus the triangle is equal to 10, or you could think of it as 2 triangles equal 10. Either way you want to think about it. It's pretty easy to see that the triangle would be equal to 5. That's not like a super difficult thing to figure out. And basically we just solved an equation, but you just never saw a variable. I didn't bring in like x or y or anything like that. But we just solved an equation using balancing scales. So now I know that the triangle is equal to 5. I don't know what the circle is equal to, and it doesn't actually matter because we subtracted it off of both sides. Let's try another one. So on this one, I have 2 balancing scales given. So it's like you're given 2 equations to help you solve. So I'm given this one, that a triangle, a circle, and a triangle equals 8. And I'm also given that 3 circles equals 12. So if I'm given those 2 and I want to start with using one of the scales to try to solve and figure out how much a shape is worth, do you think I'm going to start with the scale that's got multiple shapes or just one shape? I think it's going to be easier to solve the one that's got one shape. So this tells you that 3 circles is equal to 12. So how much would each circle be worth? You could divide both by 3, right? 3 circles is 12, or you could think of it as circle plus circle equals 12. However you want to think about it, what you'll find out is that the circle, if you were to divide by 3, is equal to 4. So the circle equals 4. That is a circle, the symbol, that's not a 0. So we know that the circle is worth 4, so I kind of started here and I kind of went down this way. And then from here, now that I know what the circle is worth, I'm going to come back up to here. And I know that the circle is worth 4, so I'm going to put a 4 in there. So I have a triangle, a 4, a triangle is equal to 8. Well, something I could take off of both sides is I could remove 4 from both sides. So I'm going to say subtract 4 from both. So if I take the 4 out, and if I take 4 out of there, I'm going to have 2 triangles are equal to 4. And that means each triangle is equal to 2. So now I solved, I know what the circle is worth, and I solved, and I know what the triangle is worth. I know you were given 2 equations, you never know which one you're going to start with. So I just started here and I know I kind of snaked my way through here, but you followed it, I hope. So that's how you can figure out the shapes. And that is actually solving equations, it just doesn't feel like it. So let me show you how this is actually like solving equations. So when you graduate then to things like this, 5x minus 12 equals 8. So your students will know if you put 5x minus 12 on the left and you put 8 on the right, since they're equal, then the 2 scales will be balanced. And we just have to make sure we maintain that balance. So I want to do something to both sides. I'm going to try to figure out what x is worth. I'm going to do something to both sides, but I have to do the same thing to both sides. So I'd like to whittle this side down. I got a lot going on over here. I'd like to have less going on over here. So let me try just adding 12 to both sides. If I add 12 to both sides, it's going to cancel out. That's going to turn into 0. And I'm just going to be left with 5x. But on this side, I'm then going to have 20. And the sides will still be balanced. And now I've got 5 x's. I only want 1, so I'm going to divide by 5, but I'm going to have to also divide by 5 over here. And if I take 5x and I divide by 5, I end up with x. And 20 divided by 5, see those cancel, that's 4. And so I end up with x equals 4. And it's just like the balancing scale is the equal sign, right? And so this is a really nice way to graduate from the pictures to the algebra. So if we were doing this just like regular algebra, I don't know if any of you were ever taught to do this, but I think it's a really good idea, is to kind of draw a line that separates, kind of like the balancing scales. And then what we're going to do is we're going to add 12 and add 12. It's going to make 0 on that side. So 5x equals 20. And then you go divide by 5. X equals 4. And this right here, doing it like the algebra way, is exactly like what we drew here. It's just the picture is a nice way to ease into it. It makes it seem not so scary because they can tie it back to something that they've already done. So that's balancing scales and solving equations.